Limiting the amount of ballast taken is the first step in an effective ballast management plan. Practices that minimize the intake of port and coastal sediment can also be effective in reducing aquatic introductions. Ballasting should be avoided in very shallow waters, in stagnant areas, in the vicinity of sewage outflows and dredging operations, in areas where target organisms or known pathogens are present, etc. Whenever practical, the loading of ballast should be delayed until the ship is in open ocean waters. Ballast water exchange is currently considered the single most practical method for ballast water management. Ballast water exchange can be accomplished by either the sequential empty refill method or by flow-through, also referred to as the overflow method. It has been reported that these methods are about 95% effective in eliminating aquatic organisms. Ballast water exchange operations should be performed in deep water, away from coastal shelves and estuarine influences. Sequential method is where all ballast tanks are completely emptied and refilled at sea, step by step, one or more tanks at a time, until all ballast has been replaced. The sequential method requires considerable planning to ensure that the ship will remain within accepted criteria. The primary considerations in assessing sequential exchange scenarios focus on vessel stability, hull girder strength, propeller immersion, bridge visibility, list angle, and in addition, the effect in slamming, sloshing, and damage stability. The flow-through method, whereby tanks are overfilled by pumping in additional water, has the advantage that it can be used in weather conditions which would be marginal for use of the sequential method, since there is little change to the condition of the ship. Research has established that it is necessary to pump in 3 times the volume of the tank to achieve a 95% change of water. Pumping in only once the volume of the tank produces a 63% exchange. Twice the volume produces 86% exchange, while 4 times the volume produces a 98% water exchange. All ballast exchange must be carefully planned, and the following aspects should be taken into consideration. Avoidance of over and under pressurization of ballast tanks. Free surface effects on stability and sloshing loads in tanks that may be slack at any one time. Admissible weather conditions. Weather routing in areas seasonably affected by cyclones, typhoons, hurricanes, or heavy icing conditions. Maintenance of adequate intact stability in accordance with an approved trim and stability booklet. Permissible seagoing strength limits of shear forces and bending moments in accordance with an approved loading manual. Torsional forces where relevant. Minimum-maximum forward and aft drafts. Wave-induced hull vibration. Documented records of ballasting and/or deballasting. Contingency procedures for situations which may affect the ballast water exchange at sea, including deteriorating weather conditions, pump failure, loss of power, etc. Time to complete the ballast water exchange, or an appropriate sequence thereof, taking into account that the ballast water may represent 50% of the total cargo capacity for some ships. Monitoring and controlling the amount of ballast water. If permissible by vessel's draft, one alternative is to retain all ballast on board. If the vessel must shift her ballast while in port to maintain list or trim, this should as far as possible be done without discharging any ballast. If ballast exchange has not been possible, some ports have the facilities to receive ballast water ashore. When ballasting a vessel, there will always be particles and mud entering the ballast tanks together with the water. These particles and mud will form sediment. This sediment has to be removed at regular intervals. Consult the ballast water management plan on board your vessel, or ask your ballast water management officer about the interval. The sediment can contain more harmful species than the water. Only dispose of sediment in mid-ocean or to a reception facility ashore. In case of an emergency, the local authority must be contacted before any ballast water is pumped out in the sea. The possibilities in an emergency can be a decision not to treat, physical treatment, for example heat or UV radiation, and chemical treatment, chemical sanitization. The Convention promotes new techniques for ballast water management. The requirements for new techniques are: it must be safe, it must be environmentally acceptable, it must be cost-effective, it must work. At the time of producing this CBT, there are no other approved techniques than ballast water exchange. However, there are several techniques under development. Here are a few of them. Mechanical treatment methods, such as filtration and separation. Physical treatment methods, such as sterilization by ozone, ultraviolet light, electric currents, and heat treatment. Chemical treatment methods, such as adding biocides to ballast water to kill organisms. Various combinations of the above. Ballast water can be filtered before it enters the tanks or while it is being discharged. The advantage of filtering as water is pumped into the tanks is that organisms that are filtered out may be retained in their native habitat. If ballast water is filtered while being discharged, proper disposal of organisms is required to eliminate accidental introductions. One of the main drawbacks to filtration is that it requires specialized equipment, which may be expensive to purchase and install. The cost of filtration increases as smaller particles and organisms are removed from ballast water. Since the sizes of filters used to treat ballast water are not likely to remove microorganisms, another treatment method would have to be used to remove microbial invaders. New technologies are developing ways to increase the flow rate through filters and prevent organisms from clogging filters, making this method of treatment more useful. Heating ballast water to temperatures between 35 and 45 degrees Celsius and maintaining that temperature for a long enough period of time is effective in killing larger organisms such as fish, but not as effective in killing microorganisms. Ballast water is heated by using the engine cooling system, either by using ballast water to cool the engine or by flushing ballast tanks with the heated water that was used as coolant. This is a very efficient method because coolant water is necessary and would most likely be discharged into the ocean if it were not used to treat ballast water. Another benefit to this method is that there are no resulting chemical byproducts. There are a few different chemical treatments developed today. Here follow some examples of chemical treatment. Biocide, a chemical such as bleach that kills organisms. Oxidizing agent, chemicals that destroy cell membrane through oxidization. A molecule that is electron deficient removes an electron from another molecule in this reaction. The process of rusting is an oxidation reaction. Non-oxidizing biocide. Biocides can also be lethal through various other chemical means. Ozone. This molecule, O3, is very important in our upper atmosphere. Here it shields us from harmful ultraviolet rays. In the lower atmosphere, however, it is the major component of smog and is a harmful pollutant. It is also often used as a biocide in water. Ozone is inherently unstable and dangerous to produce, but it is a very powerful oxidizing agent. Studies have shown that if ballast water stays in a ballast tank for a year or more than 95% of the aquatic life and pathogens are dead. However, this is not an approved method. There is unlikely to be any need for crew members to take samples except at the express request and under the supervision of a quarantine officer. Ballast samples should be taken through sounding pipes if possible. If necessary, then manholes can be used for ballast and sediment sampling. If sediment sampling requires tank entry, an enclosed space entry permit must be issued before entering. After completion of this, ask your ballast water management officer about the location of sampling points for the ballast tanks on board your vessel.